All right, in the last presentation, we talked about multiplying and dividing square roots. In this one, we're going to talk about higher radicals. We're going to talk about cube roots, fourth roots, fifth roots, etc., and see how we can apply what we looked at in the last presentation to this one. So we still have the same rules. We have the product rule, which says the nth root of A times the nth root of B is equal to the nth root of A times B. As long as your indices are the same, you can multiply the insides together or separate them. Similarly, for the quotient rule, if you have the nth root of A over the nth root of B, this is the same thing as the nth root of A over B. Again, as long as your index is the same, you can either combine or separate. All right, so let's go ahead and look at some examples. So let's start off with some basic ones. We have the cube root of 4 times the cube root of 5. This is separated, so I want to go ahead and combine it into a single root. So we're going to go ahead and have a cube root of 4 times 5, which is 20. And we're done. If we look at example B, we have the cube root of negative 72. I want to separate this. And so one of the things that we want to look at when we do this is we are looking for cubes now, not squares anymore. We are looking for cubes. And so our cubes, we have 1 cubed is 1. We're going to ignore that because that's true of all numbers. 2 cubed is 8. Does 8 divide into 72? The answer is yes. So I'm going to separate this into the cube root of 8. Remember that we can also take cube roots of negative numbers, so I'm going to put my negative in this first set, and I'm going to put the leftover in the second set, which is 9. 9 is a square, but it is not enough to be a cube. So now we can go ahead and simplify this. The cube root of negative 8 is negative 2. And we leave the 9 inside the cube root. Now if you want, if you struggle with knowing your cubes and your higher root and your higher powers, you can go ahead and do this using factorization. So I'm going to ignore the negative for now, and I want to factor 72. So if we look at any two numbers that multiply to 72, I'm going to go with 2 and 36. 36, I'm going to go 2 and 18. 18, I'm going to go 2 and 9. And 9 is 3 times 3. Now the important thing to note on this is a cube root. So I am looking for groups of 3. I have 3 2s. Therefore, that is what is going to go outside. I'm going to pull out 1 2. Because I take the cube root of 2 cubed is 2. My 3 times 3, this is not enough. This is not enough. I only have 2 3s. They cannot come outside because, again, we're looking for groups of 3. And then again, the negative, I can pull it out because the cube root of a negative number is also a negative number. Okay, let's try one more example. Let's look at the cube root of 16, a to the 7th, b to the 14th. Again, I want to break this down into cubes and non-cubes. So 8 is a cube, and it divides into 16. My leftover will be 2. Now, for our variables, I want an exponent that is divisible by 3. And so a to the 6th is divisible by 3. And what do we have left over? We have 1 left over. B to the 14th, I can do B to the 12th. 12 is divisible by 3. And what do we have left over? We have B squared. 12 plus 2 gives me 14. And now we can go ahead and simplify this. The cube root of 8 is 2. If I take the cube root of a to the 6th, when we talk about cube roots, we're going to divide by the index. 6 divided by 3 is a squared. 12 divided by 3 is 4, so we get 2, or b to the 4th. And then we keep all of our leftover stuff inside the cube root. So we get 2a squared b to the 4th, cube root of 2ab squared. So let's go ahead and do this using factoring, including the variables. So 16, things that multiply to 16, I have 4 and 4. 4 is equal to 2 times 2 for both of these. So we get 16 is equal to 2 times 2 times 2 times 2. Again, what are we looking for? We are looking for groupings of 3. I have one group of 3, therefore I have 1, 2 that can come outside. And my leftover 2 will stay inside. Okay, let's look at a to the 7th, and let's write this out in expanded form. So a to the 7th, I have 1, 2, 3, 4, 5, 6, 7 a's. Again, I am looking for groups of 3. How many groups of 3 can I make from 7? I can make 2 groups of a cubes. So what does that mean in terms of our answer? We can pull out an a squared, and we have a left over on the inside, my leftover a. Okay, let's look at b to the 14th. If we have b to the 14th, we have 14 b's. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Same thing, I want to make groups of 3, so I can make 1, 2, 3, 4 groups of 3. So what does that do in our answer? We can pull out a b to the 4th. I have 2 b's left over that I cannot put into a group of 3, and so we keep a b squared inside the root. The other thing that you can do is, as I mentioned, roots are where we divide exponents. If we look at our exponent of 7, 7 divided by 3. 3 goes into 7 2 times. We get a remainder of 1. 2 becomes my outside exponent, and 1 becomes my inside exponent. Same thing with 14. If we divide 14 by 3, 3 goes into 14 4 times, gives me 12. Subtract, we get a remainder of 2. So what does this result in? 4 is my outside exponent, and 2 is my inside exponent. So those are some different ways that you can go ahead and solve these problems. All right, let's go ahead and look at a couple more examples. I think we've beat these ones to death. So let's go ahead and talk about simplifying in terms of multiplication. Let's do a little bit more of that. So this first problem we have is 3 cube root of 25 times 2 cube root of 5. So the first thing that we're going to do is I want to go ahead and multiply my outside numbers. Everything here is being multiplied. We get 3 times 2 is 6. And then I can multiply my inside numbers. We get cube root 25 times 5 is 125. Now I can take the cube root of 125. The cube root of 125 is 5. And again, remember everything here is being multiplied. So we get 6 times 5. This simplifies down to 30. All right, we've played around with cube roots quite a bit, so let's go ahead and look at a fourth root. So fourth root, the first thing I want to do is go ahead and combine this into a single radical. If we combine this into a single radical, I get the fourth root of 8 times 4 is 32. X cubed times x squared, I'm going to add my exponents, I get x to the 5th. And y to the 5th times y cubed, if we add our exponents, we get y to the 8th. Now, if you struggle with cube roots, then you probably struggle even more with fourth roots. So I'm going to go ahead and factor this. So 32 is equal to 4 times 8. 4 we have 2 times 2. 8 is 2 times 4. And 4 is 2 times 2. Okay, so what are we looking for? Remember that we are looking at fourth roots, so we are wanting fourth powers. We are wanting groups of 4. So if I look for a group of 4 2's, we do have one of those right here. That means that I can pull out 1 2, and inside I am going to leave 1 2. Okay, x to the 5th. If we go ahead and factor this out, this is 5 x's being multiplied together. How many groups of 4 can I make? I can make one group of 4. So I'm going to pull out 1x. I have 1x that I cannot put in a group, so that 1x will stay inside. So those are our x's. So now let's look at our y's. we have 8 y's. We are wanting groups of 4. I can make 2 groups of 4. So that means I can pull out a y squared. Do I have any y's left over? The answer is no. And so this is our final answer. Okay, so these are some examples of multiplying, but we also said that we wanted to do some division. So let's go ahead and look at some division problems. Let's start with F. The first thing I want to do is, again, I want to go ahead and combine my outsides and my insides. So on the outside, I have a 5. I'm going to bring that down. On the insides, we can go at, since we do have same indices, we can go ahead and divide. And so we get the cube root. 32 divided by 2 is 16. All right, cube root of 16, we looked at this one earlier, so remember that this is equal to the cube root of 8 times the cube root of 2. This is being multiplied by the 5. Remember, everything here is being multiplied. And so now we can go ahead and simplify the cube root of 8. Cube root of 8 is equal to 2. And now that it is outside the root, I can go ahead and multiply it with 5. So we get 10 cube root of 2. That takes care of example F. All right, let's look at example G. Example G, we have the 4th root of 729, a to the 9th, b to the 5th, over the 4th root of 3b. So the first thing I'm going to do is combine this into a single root. If we go ahead and divide, I can combine my insides. 729 divided by 3 is 243. I still have my a to the 9th. And b to the 5th divided by b, I'm going to subtract my exponents, and I get b to the 4th. Now, 243 is actually not that bad of a number. Let's go ahead and see what we can do here. 243, this is divisible by 9. And if I divide by 9, I get 27. 9 is equal to 3 times 3. 27 is equal to 3 times 9. And 9 is equal to 3 times 3. Okay, what are we looking for? We are looking for groups of 4. I do have one group of 4, so I can pull out a 3. I have 1 left over, so it will stay inside. All right, a to the 9th. How many groups of 4 can I make with a to the 9th? Well, if I have 9 a's, I can make 2 groups of 4. So that means I can pull out an a squared. And I have 1a left over. That will stay inside. b to the fourth, we kind of looked at this in the first section for radicals. Fourth root of b to the fourth is just b. We have nothing left over. If you need to, you can also expand this out. How many groups of 4 can I make from b to the fourth? Well, we can make 1, and we have no leftover. So that's going to take care of the problem. We get 3a squared b, fourth root of 3a.